Hi everyone, my name is Ryan Paul, and my Comenius project for you guys this year is titled The Iterative Development of Algorithms and Sensor Fusion Towards Accurate, Efficient, and Affordable Applications to eventually improve independent mobility for the vision impaired. I'll cover everything from this project from its cause, the overall objective, to final research and the devices built. And I'll go over why I did this project, how it started, how it came to be, and then I'll explain how this project will be extended further. So in my 10th grade summer, I took an internship. I took a work experience, and from this work experience, I was responsible for managing and building applications, well, navigational systems for the visually impaired. And through this experience, I took about 20, 30 interviews with people responsible for the visually impaired, actually people who are visually impaired themselves and responsible for large communities. And that was a truly amazing experience. And one takeaway that I learned from that particular experience, particularly to one person actually, her name is Sarah. She expressed to me through her daily life the technological advancements and infrastructure that's available today, and one that's growingly apparent as I've seen through many different companies now that are helping with the visually impaired and navigating through stores. And what I saw is that the technology available today is not only expensive, but it doesn't provide the quality that's sufficient with today's current technology. And I learned that um, throughout this whole project that these devices, these implementations can be developed much more affordably and can help the consumer much more. So my goal for this project, my actual overall objective, I like to do these like poster presentations. That's how I usually do it. But my objective with this is how can I create an affordable and efficient system? Um, and I learned that it can be easily doable with new and previously unconventional wayfinding algorithms. So I use those to plan this project itself, and I'll go in more into that later. And all of this is separated into two versions, Mark 1 and Mark 2. And in total, this whole project costs around $700. Relative to other technology today, that's very cheap. That's very affordable in today's marketplace. So as the technology gets better and better, the smaller the price will be, and ultimately, the more accessible it is to blind users. A little bit of a background, about 50% of the visually impaired have never traveled an unfamiliar environment before, and 90% of them uh, they avoid traveling unfamiliar routes. They travel about once a week. And two studies that I found that I thought were representative of this field in general were one where they developed a wearable device, but it was very heavy and it was very expensive due to the cost of the LiDAR sensors. So it wasn't accessible. It can't be a tool that we use in everyday life. That's why it was in a study. They're testing the use of LiDAR sensors for the vision impaired. And another one is around augmented reality and semantic representation. And this required like Bluetooth beacon networks, systems that even were implemented would require a much stronger infrastructure, and this wouldn't be applicable for daily use. Um, in many senses, this industry, I think, is most heavily affected by the lacking commercial advancements in certain sensors. And ultimately, my ultimate goal was to take advantage of the current uptick in availability of these sensors and incrementally scale down the price in hopes of achieving a minimal viable product that's valuable. So this whole system actually, I split it into computational and engineering methodologies. They actually could be split either way. Um, but I think with this kind of project, the computational methodology is the heart of the project. Um, with engineering solutions, right, it just depends on the cost of the sensors, the current code infrastructure that's you're able to easily use your application, your algorithms on, and that ultimately determines the price. So that's how this project, as it goes more and more, will get cheaper. But this project, I have 4 algorithms: simultaneous localization and mapping, obstacle avoidance, GPS waypoint tracking, and object recognition. So basically how this works is the simultaneous localization and mapping algorithm. It creates a virtual environment around the user, depending on the LiDAR sensor it is equipping. So the one for this project is around 9 meters. So it'll create a circle around you within 9 meters, and within that, it will filter out the obstacles, and then you'll use A-star pathfinding, presuming you already put a location and say you want to go to. For me, let's say I want to go to that door, it will plan the most efficient path around those obstacles into your pre-planned destination. Obstacle avoidance, it's a more generalized algorithm. It's when you don't really know where you're going, but you're going in unfamiliar environment. So how it works is it uses distance thresholds. So say you're within 2 meter, well, I think it's around 2 meters or within an object. It will first detect that using the LiDAR sensors, because LiDAR sensors can give you precise distance coordinates and determine the obstacles relative to you. And it'll be able to use whatever feedback method is available on the engineering prototype to steer you away. The GPS waypoint algorithm basically it's basically a generalized GPS algorithm with more steps. How it works is, say I wanted to go to my nearby coffee shop. It'll first take me to this door, then it'll take me down the stairs, then it'll take me step by step by step, accomplishing each waypoint until its final destination. And then lastly, we have object recognition, which basically works using object detection to locate important signs like stop signs or yield signs, in hopes of a safety measure, so the visually impaired and unfamiliar environment don't go across the street and potentially be a safety hazard to other people. And throughout this project, I created 2 versions. These algorithms are very flexible, so they can be used for multiple sensors, multiple purposes. But for this, I used an open source study that already did this kind of similar thing, but it worked in different sensors, and that's how I was able to test my algorithms in the first place. It used the LiDAR sensor, a breakout board, inertial measurement unit, and putting this all together with a container. This was around $550, and this was a proof of concept that the algorithms were sufficient for this use case, and that it was able to work effectively. That was the first step into this kind of project, and even $550, that's very cheap. That's much less than the thousands of dollars in other applicable technology. And then Mark II, I wanted to create an engineering prototype that's much cheaper than all relative technologies today. So this Mark uses your iPhone, which has all the sensors available now, because Apple's previously scaling up on all its devices, 12 Pro and up, on implementing LiDAR sensors. So now on your phone, instead of all these clunky prototype sensors, you'll be able to run the software that I'll ultimately develop. And this costs around $120, significantly cheaper than all the current technology infrastructure for today's application for this specific use case. This project has been a major success so far for me. I never expected to get this far, and I'm lucky that now I even get to talk about limitations. So the first part, lack of human participants. I'm currently actively seeking these kinds of environments where I can actively test my product in pilot testing. So as time goes on, I'll be able to run pilot tests and get that deliverable into a more scaled version to actually help more so the visually impaired. And then technological limitations. This basically is the current infrastructure today. As technology gets more improved, there'll be more technology available where, hey, now LiDAR sensors can support 20 meters instead of 9 meters. It'll improve the accuracy of these types of applications and ultimately scale it up with hopefully a lower price. So that's my project in a nutshell. As it goes on, to make this more readily available for the commercial user, this will be scaled with an auditory interface and all those current applications instead of a bare bones application, to eventually serve as the premise for help the visually impaired one day. Thank you so much for listening. I hope you learned a little bit from this brief session with you and I. And I'll let you know as the project gets more and more improved. Thank you so much.